Hello, and welcome to Verisk's Emerging Issues. My name is Greg Scaletti, your host for today's webinar, and I am a member of the Emerging Issues team here at Verisk. And today we are talking about solar panels. We'll take a quick look at the adoption of solar power across the United States, and then dive into a look at solar panels and fire risk, and conclude with a look at solar panels and hail and some of the climate considerations that we have been studying on the team. So what you're looking at here is a high-level representation of the emerging issues research framework, basically the steps that we take when dealing with emerging risks on the team. And you can think of this a bit like the life cycle of emerging risk research here at Verisk. And I'm sharing this because solar panels, solar power, are obviously a very well-established risk at this point. And we have several Verisk products that address this risk and address solar panels. But we continue to monitor this issue because, as I hope we can demonstrate, there's still an evolving element to solar panels and solar panel risk. So first, just to set the table a bit here, these are the U.S. Energy Information Administration's figures on the growth of small-scale solar capacity throughout the United States. And as you can see, probably no surprise to anyone, it continues to grow, and it is forecast to keep growing at least out through 2026. And we can contextualize this growth a bit more at the residential level by looking at other major home renovation products and projects. And this is data from our property estimating solutions colleagues. And as you can see, over the past several years, people have really bought into solar, both literally and figuratively. And you can see here it compared to pools, home additions, baths, and kitchens. Further bit of context here, we are looking at regions of the country that are onboarding solar panel. Again, this is from our property estimating solutions colleagues. This is their estimate of total solar panel exposures across residential properties. So we know that solar is growing, that's obvious, but how are solar panels influencing, at least potentially influencing, property risk? Well, let's start with fires. And there's kind of three ways I think we can think about this challenge. The first is the potential for a solar panel to start a fire. The second is the potential for panels to get damaged by fires and the possible costs that that damage could have for insurers. And finally, there is the impact that panels may be having on either impeding or interfering with first responders, with firefighters. So let's take that first concern, the possibility of a panel starting a fire. And the first thing to note here, at least, is the macro trend. We have, as I showed previously, right, those energy administration figures, we have more solar panels than ever before, small-scale solar panels, but we've seen a decrease over time in residential fires. Now, those two dates don't line up perfectly well, but they line up close enough to give us a sense, I think, at the macro level that one trend doesn't appear to be influencing the other. Now, we also looked at this question from the perspective of what we could learn from academic surveys, especially internationally, where there appears to be a lot of data collection on this question. Now, what we have seen from the literature, and I've summarized it here on the slide, you can see fairly low frequency when it comes to residential solar panels starting a fire. We've actually had data collected from Massachusetts. This is reported data in media reports from Massachusetts, showing just 16 fires over a 20-year period, at least fires reported. And you can see in Germany as well a very low frequency. Now, what do we know about why these fires can start? We surveyed the literature here and we kind of distilled these broad patterns. Again, they're fairly obvious, but we can highlight two elements here. And the first is panel component failures. Obviously, a component failure may lead to a fire. In Germany, for example, there are an estimated 15% of the country's entire installed solar capacity could be at risk of a component failure, a specific type of component failure called a backsheet failure. So backsheets are a protective layer of a solar module. They help keep the internal components protected from the elements. A second possible contributing factor here is age. Panels can degrade over time, and those degradations, including to the backsheet components, those can lead to vulnerabilities that may increase fire risk. Now, There was a study by the National Renewables Energy Laboratory that suggested about 1 million metric tons worth of solar panels in the US are expected to reach the end of their operational lives by the year 2030. It's not clear from that study the breakout between commercial or utility systems versus residential systems, but the National Renewables Energy Lab did note that panels last on average between 25 and 35 years. So we know the clock is ticking on the residential solar installation base in the United States. So it might be reasonable to expect, at least for the potential for the number of solar fires to increase as this install base continues to age. Now, I want to underscore again that speculation. And this last issue that we flagged here, the use of panels as architectural elements. This is something we may see more of in the future. Solar panels may not be the most sightly addition to a home. Your mileage may vary there, but there are efforts to make solar panels look more like architectural elements, such as roof tiles, for example. And there was a study out of Italy that suggested that the use of solar panels and conforming them to different architectural styles may increase the risk, even modestly, of a solar panel starting a fire. But there's another element to consider with solar panel fire risk, and that is the growth of the systems that are being sold to capture solar energy. And these are battery energy storage systems. They're typically lithium-ion battery-based systems, and they are increasingly attached to solar panel installations. And that's solar panels at all level of deployment, so from residential all the way up to utility scale deployments. And you can see here about 13% of all solar panel systems in the US are now sold with an attached battery. It's much higher in places like California. So whenever we talk about lithium-ion batteries, right, there's always a concern about those batteries contributing to fire risk. Now, based on our review of third-party data, and it's shown here, and it's sourced in the appendix to this presentation, but fire does not appear to be a frequency story with these systems, at least to date. You can see there have been about 60 fires reported globally since around the year 2020 involving residential battery energy storage systems. So not all that many in absolute terms. But these fires can be a severity story based on the nature of how lithium-ion batteries burn. I won't rehash this entire slide. I think we're increasingly familiar with the story around lithium-ion battery fires. But suffice it to say that these battery systems, which are being increasingly connected to solar panels, may sort of contribute to the overall picture of fire risk with solar installations. And obviously, lithium-ion battery fires can be very challenging from a firefighting perspective. They burn hotter, they can reignite. There is the potential for these systems even to release toxic chemicals in the smoke when they do burn. So a lot of considerations there. And now we'll look at what Verisk's claims data can tell us about these fires. Now, important to note, these are fire claims irrespective of the cause. So it might include instances where the panel is starting the fire, but it is also including instances where a panel is damaged by a fire. And as you can see here, fire represents a very small percentage of overall claims, but that loss figure of around $9,000, that is much higher than the average property loss claim. So as I mentioned, fire appears to be a severity issue in this respect. And the last element here, the impact that panels may have on fire fighting. There are a number of considerations here, but they basically sum up to at least the potential for solar panels to contribute to a fire's severity because they may impede or slow down first responders. Now, it should be said, obviously, with the growing installation of solar panels in the United States, obviously fire departments getting better and better at managing these systems and fires involving these systems or in structures that have these systems, but it's still a confounding variable, at least for now, that first responders have to consider. And the last peril I wanted to discuss today is hail. According to Verisk data, hail is responsible for the lion's share of damage claims. Probably no surprise there. They are right in the line of fire, if you will. But there are a couple of aspects of hail that we can discuss. The first is hail size. So solar panels in the US may be tested against a UL standard, for example, UL 1703. And this is a certification that signifies that a panel has been tested to endure the impact of a 1.3-inch hailstone falling at terminal velocity, or the impact of a 1-inch stone fired from a pneumatic cannon. So that's the lab scenario. But in the real world, it appears that panels, they may not always hold up as well. A 2024 study from the National Renewable Energy Laboratory noted that panels can show performance degradations, which is in this case a proxy for panel damage. They can show these degradations after enduring hailstorms with stones about 1 inch in size, so smaller than the stones that they're being subjected to in lab tests. And not all damage to a solar panel may always be visible. Panels can contain what are called microcracks, which are very difficult to identify visually, but which can over time lead to degradation. And not just degradation, but it can make the panels more vulnerable to future storms. So these little microcracks are basically little pathways, little gateways for water, for dust intrusion, all of which may play a role in influencing that fire risk I was just mentioning. And the other issue with hail is that atmospheric hail can be a lot larger actually, than the 1.3-inch stones or metal balls that are simulated hail in the lab. So hailstones from severe storms can typically span between 1 or 1.75 inches, and they can get as large as 4.5 inches. So just imagine ice the size of a grapefruit pelting a solar panel. And the story of hail is evolving. And this is information courtesy of our location team at Verisk. And they've noted a general trend towards increased stone sizes, hailstone sizes. You can see the Northeast here appears to be seeing more days with 2-inch or larger hail. And obviously that could be a significant issue with panels because I mentioned those are stones that are larger than what these panels are being tested for today. Now, there is, I think, somewhat of an open question of how climate may be influencing hail risk. That's a very large issue, far too large to grapple with in this webinar. But one theory is that a warming planet may actually reduce the frequency of hailstorms generally, because a warmer atmosphere will serve to melt stones before they have a chance to reach the ground. However, what hail is left in the atmosphere as a result, at least according to this theory, may wind up being larger. So we may see a trend, at least potentially, towards less frequent hailstorms, but potentially larger hailstones. And again, at least that is a theory. Now, there does appear to be some performance differences in solar panels based on their precise type. For example, there was a study published earlier this year that noted that the number of bus bars within a photovoltaic module was a key factor in influencing a module's resilience to hail impacts. So bus bars basically wire solar cells together to create higher voltages. And what the research found was that the more of these bus bars you have, the more resilient these panels appear to be to hail damage. And it's not just the sheer number of bus bars, but also the panel type. So these researchers found that monocrystalline panels showed better hail resistance than polycrystalline panels, even when you account for the number of bus bars. So again, monocrystalline panels, at least in this study, showed better hail resistance than polycrystalline panels. So that concludes our very brief webinar today. I want to thank you for listening. If you want to learn more about emerging risks facing P&C insurers, I would encourage you to subscribe to our newsletter using this QR code here. We release it every week, and we track a number of emerging risks across any line of business that Verisk supports. If you have any questions on this or other emerging risks that you or your teams may be following, please do reach out to us on the email you see on your screen. And thank you very much for your time.